Visible light is just one of the types of radiation emitted by the sun, along with a whole spectrum of other electromagnetic radiation which is invisible to us. This radiation is commonly described as waves, but can also be thought of as particles, known as photons, that travel at the speed of light. Radiation is all around us, coming from a range of sources. Some of these are natural, such as rocks, bananas, and even your own body, and some are manufactured. A standard house lamp emits visible light, just like the sun. And when we want to cook popcorn, we use microwaves, which is another type of radiation produced as part of the sun's spectrum. When radiation is at low energy, it can pass through our bodies without us even knowing about it, such as radio waves from Wi-Fi. Infrared light, however, is also low energy, but can be felt by our skin as heat. It's emitted by any object that has a temperature, even cold ones like ice. However, radiation at high energy, such as X-rays, can cause harm to biological cells, so we have to be mindful of how much we're exposed to. To do this, we can measure it using a Geiger counter. As we travel up into space, away from the Earth, we experience higher doses of radiation that mostly comes from the sun. On Earth, we're protected from some of this radiation partly by our powerful magnetic field, which, along with our atmosphere and ozone layer, stops too much radiation reaching the surface, providing enough as a source of energy for plants to photosynthesize and allowing us to see things. Here on Earth, we've learnt to use visible light every time we take a picture. Early cameras relied on paper coated with light-sensitive chemicals that react to light to produce an image. The more light that falls in one region of the paper, the brighter that part of the image, and so gradually a picture can be built up. Modern digital cameras contain sensors that do the same thing, but instead of paper, they're made of materials like silicon that are also sensitive to light, specifically photons. These sensors are subdivided into pixels to make up the image. Within each pixel, photons generate electric charge, depending on the brightness of light. But when we try to take pictures in space, whilst we use radiation in the form of photons of visible light to make an image, other types of radiation can have detrimental effects on the performance of electrical equipment. Much of space is a hostile environment, not only for humans, but for the robotic spacecraft and equipment designed to explore for us. This is why scientists, like those at the Open University, test camera sensors that go on space missions to make sure they're capable of capturing accurate images of the planets and stars beyond Earth, to learn more about the universe we inhabit.